Thousands of people packed a hotel lobby on a Friday night. Music played, couples danced, children leaned over railings to watch. Nobody knew they were standing inside one of the deadliest structural failures in American history. July 17, 1981. The Hyatt Regency Hotel in Kansas City was hosting its weekly tea dance. More than 1,600 people filled the lobby. Above them hung two suspended walkways. They looked solid, engineered, permanent.
But hidden above the ceiling was a design change that doubled the load on a critical connection. Nobody in the crowd could see it. Most of the people who approved it didn't understand what it would do. As the dance continued, spectators gathered on the second-floor walkway. Others crowded onto the fourth-floor walkway directly above it. The steel rods holding both structures began carrying forces they were never designed to handle. One connection started to deform, then another.
At 7:05 p.m., the fourth-floor walkway gave way. It crashed onto the second-floor walkway below. The impact multiplied the force. The second walkway instantly failed. More than 100 tons of steel and concrete slammed into the crowded lobby. The collapse lasted seconds. When it was over, 114 people were dead. Another 216 were injured. Rescuers worked through the night, cutting steel, lifting debris, and listening for voices trapped beneath the wreckage. Investigators searched for the cause. At first, many expected a construction defect.
What they found was worse. The disaster existed on paper long before the dance began. During construction, a seemingly minor design revision had been approved. A single continuous set of steel rods was replaced with a different arrangement. The change looked small, but it doubled the force on a critical connection. The safety margin disappeared. The collapse wasn't caused by a storm, not an earthquake, not sabotage, just a change nobody fully checked.
The outrage transformed engineering. Across America, structural review procedures were rewritten. Independent design checks became standard. Engineers became legally responsible for approving critical changes. Documentation requirements expanded, peer review became common practice. Today, every stadium, every airport, every skyscraper, and every bridge is shaped by lessons learned from that collapsed lobby. But what if someone had checked the numbers one more time? One engineer, one calculation, one signature. The walkways stay in place, 114 people go home. The disaster never makes history.
But then, the rules protecting millions of people today might never exist. Because sometimes the safest structures in the world are built on lessons paid for by people who never got a second chance. This disaster didn't just destroy a hotel lobby. It helped build the engineering standards that protect us every day. Disasters built this. And there is probably another one happening right now.